All right, this is checkpoint 8 for algebra connections, and we're going to work with the graphing calculator to do all this stuff. We did this in class, so I'm going to kind of rush through this a little bit. I only got maybe 10 minutes before the bell rings, so I'm going to try to do this pretty quickly. I already typed in this data in the calculator, so make sure you can do that. Go to Stat, Edit, so enter in your points. Okay, so I'll go back to that so you have them. You can pause it if you need to put them in there. I suggest you do that. It says graph it and give me the least squares regression line. So I'm going to go to, I'm going to turn my plots on. Like my plot should default plot 1. If I go double check here, go second y equals. My plot 1 is on, and it's list 1 versus list 2, and that's great. And so I've got that plot on. If I graph it now, nothing shows up there unless I hit zoom 9. And then are my dots. I still don't have the line going through it, which you do need. So we need to calculate that line best fit. So I'm going to go stat calculate 8 is the one that we prefer, and hit enter. And then there's your equation. Y equals 264.4, basically 39 plus negative 5.34x. So my slope is right there, and that's my y-intercept. Now I want to copy this into this spot right here. So I'm going to, that Control V on your computer is like, it reminds you to hit vars 5. So vars 5. I don't know why all these keys are staying red, but that's kind of cool. Vars 5, and then down to, oh, I didn't hit 5 yet, did I? Oh, it's really acting strange and slow. Let's try it again. Vars 5, there we go. Over to equation, and then just hit enter for a regression equation. So it'll copy that number in there for you. Now when you graph, it should have the line going right through it. So on the checkpoint, you will have to copy that right here best you can. Just make a nice little sketch with the line going through. Now it also asks for the windows. Okay, so in the window here, I don't know what the values are unless you hit the window. So hit window, and then just copy this list down under this list right here. So don't forget that hit window. And what's next? Record the least squares regression line. So that's that equation I just read off a second ago. In fact, I should probably write that down. Y equals, it was like 264 or something. You know what, maybe I'll just do it from the y equals now that I have it copied in here. So 264.39, 264.39, it's minus 5 point, I want to say 34x. I better double check that. Really? Really? That's a lot of decimal points. 5.34. Yep, so that'll work. And using that line, this is the tricky part. Find the predicted weight. So that's the weight on the line for a man who's exercised 7 hours per week. Now, I didn't even read this question to you. You can do that on your own. This is the actual data. Okay, 7 hours per week. He weighs 236 pounds after 6 months. But what's the predicted weight? Okay, and that's using this line, this least squares regression line. So you might have the line like this. His point, I think, is something like this, like 7,236. But his predicted weight was actually right down here. Okay, that's what we're looking for in this problem. I would just plug in 7 right here and solve it. Or you could just do second table and see if it's set up nice and go to 7. If you do that, just mention to me that you did it on the table. So right here, that's probably the quickest way actually, 227 pounds. Okay, so just write 227 pounds. Include the units. So that's the predicted weight on that least squares regression line. If I plug in 7 here, I'll get the same answer. It's like 227.01, just rounded to the nearest pound. All right, calculate the residual. Okay, I'm gonna go back to here. The residual then is the distance between the actual weight and the predicted weight. Okay, this is the predicted, which was 7,227. Did I do that right? That was different last time, 227. And then the actual weight was 236, so that's a difference of 11 pounds. Okay, so he weighs 11 pounds heavier than he should, basically, based on all the other data and where the line fits. So 11 is the residual. And would you rather have a positive or negative residual? In this case, you'd rather have a negative residual because you'd rather be weigh less if you're trying to lose weight, weigh less than you are predicted to have lost after working out so many hours per week. Okay, so I'd rather be I don't know, 215 than 236 based on that. So you want negative in this case, and then make sure you explain. The residual plot. All right, I'm going to set this up so if I go second, y equals, I'm going to turn this plot off. So I just go into it. I could turn that off. Oops, it's already on there. Hit enter. I'm going to go up and over to plot 2 now. And I'm going to make my plot 2 my residual plot. So if I scroll down here, right on the L, and type in residual there, and the best way to do that is under list here. So second stat, number 7. Now that says residual. So it's going to do list 1, comma, residual for the lists. And graph that. That's not going to show up. We have that line there we can delete in a second. So if I hit zoom 9. Let me clear this out of here. Clear. All right, for some reason those aren't showing up. Oh, do I have my plots on? I don't have my plot on, that's why. I thought I turned that on. Go over to plot 2, I guess I didn't turn it on. Turn that on, and then graph it. And zoom 9 again. There it is, okay. So there's our scatter, or not our scatter plot, our residual plot. And it looks pretty random, which is a good thing. So when I go to record and label it, you draw all the dots around here. Is it the best way to model the relationship? In this case, you can say yes, because it's random, or it's scattered, or where am I going here? Where am I? There I am. On this page. It's scattered about, and that's a good thing. You don't see a pattern. So you can say, yes, I don't see a pattern, or yes, it's random, something to that effect. And then the correlation coefficient, the R and the R squared. Here you need to turn your diagnostics on, which I don't have mine on, so I'll just do that quick. So I'm going to go second, 0, which is catalog, go down to D. So if I hit X inverse, I'm in my Ds. This is slower than your typical calculator. There it is, diagnostics on. I'm going to hit enter. Hit enter again so it says done. Now when you calculate stat calc 8, you'll get your R's in there with your equation that we found before. So my first R is, not my first R, but my R is negative 0.945. I'm writing this down for myself for later. And 0.89 for R squared. So here you write negative 0.945 is fine. R squared 0.89. So we're squaring it to get 89% here. So fill that in, but make sure you have the decimal here. Interpret the R squared. This is where you say 89% of the variability. I'm writing sloppy here, I'm just trying to rush. Of the weight can be explained by a linear relationship. I'm just sloppy, just bear with me. Relationship with, you could just say the time. Or it's actually the hours working out per week. If you can actually read that, great. That's what you put there. And then the association is actually going back to the R. So you can say because it's 0.94, it's a high number, it's strong. I want the direction, which in this case is negative. And I do want it to say linear, because we've been working with linear this whole time. So give me these 3 things here. You can write a full sentence out, that'd be great, but this is fine as long as you give me these 3. Strong, negative, linear, association, or relationship, something like that. That's it. Got through that under 10 minutes. Awesome.